Every time you hear the word energy, your mind automatically reaches for a picture, a kind of invisible fuel, a substance inside things that gets used up, stored, released, transferred, like a liquid you can pour from one container to another. We talk about having energy, running out of energy, energy in food, energy in a battery, energy in a moving car. And it feels so obvious that energy must be a real stuff inside matter, something you could, in principle, scoop up with a spoon if your spoon were small enough. And then you ask the deceptively innocent question, the one students ask and grown-ups pretend they've answered. What is energy? What is it really? And here's the Feynman-style shock. In physics, energy is not a thing you can point to, not a material, not a little packet of oomph hidden inside objects. Energy is a number, a conserved bookkeeping quantity we compute from the state of a system, and the deepest honest answer is that we do not know what energy is, in the way you mean. We only know what it does, and how to calculate it, and that's not a dodge, it's the actual nature of the concept. Feynman's classic way of getting you to feel this is to start with a story that sounds childish on purpose. Imagine a child with a certain number of toy blocks, and every day the blocks get lost under the rug or behind the couch or in a box, and the parent gets tired of the chaos, so the parent starts counting. Not by always seeing the blocks, but by accounting. If the child had 28 blocks yesterday, and today you only see 26, you don't conclude that 2 blocks cease to exist. You start looking in the places blocks can hide. You check the box, you look under the rug, you add what you find. And the astonishing pattern is that if you count carefully and consistently, the total remains the same. Blocks you don't see are still there, just moved or disguised. That's the emotional structure of conservation laws. There exists a quantity that, when you add up all its forms in all the right places, stays constant even though everything you can directly observe is changing. Energy is like that, except the blocks are not a physical object at all. The blocks are the number itself, and the places they hide are different forms of energy: kinetic, potential, thermal, chemical, electrical, nuclear, field energy, and the rules for converting and transferring between forms are the laws of physics. The shock is that energy is not one more ingredient of nature, like atoms or fields. It's a relationship, a numerical invariant, a pattern that the world obeys so consistently that we treat it as one of the deepest truths we have, and yet it refuses to turn into a simple picture in your head. You can feel this refusal the moment you try to locate energy inside something. Take a moving baseball. We say it has kinetic energy, TFRAC, 1, 2 MVA, and that looks like a property of the ball. But notice something quietly disturbing. The kinetic energy depends on your reference frame. Sit on the ground and the ball has 1 kinetic energy. Move alongside it at the same speed and it has almost 0. So where did the energy go? It didn't go anywhere. You changed the description. The energy in the ball was never a little substance in the ball. It was a number computed relative to a frame. Or take gravitational potential energy. We say a rock on a cliff has potential energy, mgh, and we talk as if the energy is stored in the rock, but the rock isn't special. The energy depends on the choice of zero height. You can set the reference level at the ground, or at the center of Earth, or at infinity, and the numerical value changes. So where is that energy located? Is it in the rock? On Earth? In the gravitational field? The honest answer is that the division is partly a bookkeeping choice. The world doesn't carry labels that say, this jewel is in the rock, and that jewel is in the field. What it carries is a structure of relationships that make the total energy come out consistent when you do the accounting correctly. That is why Feynman's answer can feel like it pulls the rug out from under your intuition. Energy is real in the sense that it is conserved and measurable and predictive, but it is not real in the naive material sense your brain wants. There is no little glowing pile of energy inside a hot object. What there is, microscopically, is molecular motion, vibrations, electromagnetic interactions, quantum states. And when you compress all of that complexity into a single number that is incredibly useful, that number is what we call energy. Can we measure energy by what it can do? The work required to lift a mass, the heat required to raise temperature, the voltage and charge moved in electrical systems, the frequencies of emitted photons, the recoil of particles, the behavior of atoms and fields. Energy shows up everywhere because it is the universal currency of change, not as a substance, but as an accounting identity that survives every legitimate transformation. And here is the final Feynman-style twist that's worth letting haunt you a little. If energy is just a number, why does nature care about it so obsessively? Why is the universe arranged so that there exists this conserved quantity at all? And why does it appear in every corner of physics? The uncomfortable answer is that just a number is not trivial. The deepest things in physics often are numbers and symmetries and invariants, and the world is not obligated to match the kinds of things your senses evolved to handle. Your senses evolved to keep you alive on a certain scale, not to deliver the ontology of the cosmos. Energy is the kind of concept that only becomes visible when you do what physics does best. Stop asking for a picture and start asking for a rule that connects phenomena, a rule that is reliable enough that you can bet your life on it. That is why Feynman's answer is shocking, because it forces you to admit that one of the most important things in science is not a thing at all. It's a conserved bookkeeping quantity whose existence is tied to the uniformity of time, and whose power lies not in being visualizable, but in being universal. And once you accept that, you start to see the world differently. When a light bulb glows, when a car brakes, when a star shines, when your body warms, you stop imagining energy stuff moving around, and you start seeing transformations, patterns changing form, while the accounting remains perfect. The shock isn't that energy is unreal. The shock is that the universe can be so deeply governed by something you can hold in your hand, something that lives most naturally not in your senses, but in the structure of the laws themselves.